Alright guys, so the first part, let's continue with the review for the final. The first part, we're dealing with tangents and perimeters. So looking at question number 1, and this side right here it is forward. I'm going to say this other tangent right here is forward. And the instruction says find the perimeter of each polygon. Assume the lines which appear to be tangent are tangent. So we're going to call that forward. Looking at this whole side, since the whole thing is 11.6, part of it is forward, I'm going to say the remaining is 7.6. Right, I subtracted the two numbers. So since this is 7.6, I'm going to say this other tangent here it is 7.6. Looking at this whole thing, since the whole thing is 15.6, right, it's there. The whole thing is 15.6, part of it is 7.6. I'm going to say the remaining part is 8. And then this side right here it is 8. So now for the perimeter, when I add this side, I'm going to say 11.6, right? I had the number to begin with. When I look at this other side, I'm going to say the whole thing is 15.6, right? I had the number to begin with. When I add this third side, I'm going to say it's 12, because I added the 8 and 4. So now for perimeter, add all three sides. We get 39.2. Alright guys, so 39.2. Remember, for perimeter, you're adding all the sides. Alright, so on the review, we have 6 of these. 1 through 6 on the review. On the test, there's 4 of these. I know I tried avoiding decimals, but these you can do. You will have decimals on this one. Any questions on the first 6? Alright, so let's take a look at the next section. Starting number 7. Find the angle measure indicated. Assume the lines which appear to be tangent are tangent. So I see 34 degrees. Then I see a radius and a tangent. I know in the radius and the tangent, when they cross, this whole thing is 90 degrees. So I see I have 2 angles. I know a triangle has 3 angles. Those 2 angles must be the angles of a triangle. So what I'm going to do, first let me add these 2, 90 and 34. I know 90 and 34 is 124. Let me subtract that from 180. 124 subtracted from 180 should give you guys 56. So there is one angle out there that is 56 degrees. And then the way I'm going to find out which angle, remember these 2 angles are in a triangle. The missing angle of a triangle is 56 degrees. So I'm going to say this one. Not quite yet. So I know that's 56. Then my question is, like, I should know that that's 56 for a reason. I'm looking at an isosceles triangle. I'm looking at this triangle here, this isosceles. I know it's isosceles because this is a radius and this is another radius. So they're the same length. Because those are the same length, I'm going to say these 2 angles here are the same measurement. Right? I know we dealt with isosceles. So what I'm going to do, I see this triangle here. I'm going to say 180 minus 56. 180 minus 56 gives me 124. Now I'm going to split that 124 evenly in these 2 angles. Basically, I'm going to go 124 divided by 2. So each of these 2 angles is 62 degrees. And we're not quite done yet. Okay, now the last step, you notice how 62 and the angle we need to find, we know that's 90, right? Because I had 124, because remember I went 180 minus 56 gave me 124. And I divided evenly into both. So 124 divided by 2, 62. Okay, so now, notice how this 62 and this angle, the angle we need to find, it's 90 degrees. Right, because there's a radius and there's a tangent. I know those 2 combined is 90. If one of them is 62, how big is the other one? 28. Good. Because we just, yeah. So 90 minus 62. Did you just say she doesn't care? All right, so once again, this might take a few steps. When there's a radius and there's a tangent, you know that's 90 degrees. Like that gives us 28. There's another kind that we're going to be looking at, and it's going to be simple as like number 8. There's another way. We can grab a protractor and measure it. But no, I'll tell you in a minute. Hold on, just one thing. So, one thing that we have, let me take a look at another case, but still looking for an angle in this shape. See how there's an isosceles triangle here. And I know it's isosceles because this is a radius, this is a radius. That means they're the same length. Since those two are the same length, this is 35. This one right here should also be 35. Because it's the same length. So now, I might come and ask myself, well, why do I need to know those are 35? Because they create this triangle. I know 35 and 35 is 70, right? If I combine it, it's 70. Let me subtract that from 180. 110. So this third angle here is 110. Now, let me take a look at the kite. What I mean the kite is this one right here. I know these two corners are 90 because it's made by a radius and a tangent. So I know those two corners are 90. This is 110. And I told you guys in a kite, if the two angles at the side are 90, these other two add up to 180. So this is 110. How big is the other angle? 70. So we just went 180 minus 110. So there's two kinds we guys will look at. You notice number 7, we needed to find a few angles. Number 8, we needed to find a fewer amount of angles. So on our review, we have questions 7 through 12. On the test, there's 2 of these. So I said from the review, 7 through 12, that kind, there's 2 of these on the test. 2. They could be as easy as number 8, or they could be a little more complicated like number 7. 9? All right, so looking at number 7, I have that 50 degrees. Then I see here's a radius, here's a tangent. I know a radius and a tangent, they cross at 90 degrees. So then I'm looking at, all right, 50 and 90, when I add them, is 140. 50 and 90 is 140. Let me subtract that from 180, so I get 40. There is one angle that is 40 degrees. And the one angle is, I see these two angles. The one that is 40 degrees is the one angle that completes a triangle. So this one right here, this one's 40 degrees. You guys see it completed my triangle. So again, the way we came out with 40 was, we added 90 and 50, it's 140, subtracted from 180, so that's how we know it's 40, and then we find out this angle right here. But then, I see this is a radius, this is a radius. I'm looking at this little isosceles triangle. If this is 40, I'm going to say this other one right here, it is also 40. Because it's isosceles. Now, 40 degrees, I'm going to put it right there. 40 degrees, and the one we want, make half of a circle. I know half of a circle is 180. Once again, the 40 degrees and the angle we want, they complete half of a circle. And I know half of a circle is 180, so if the angle I have is 40, how big is the other angle? 140. Perfect. Once again, There's only a pair of questions this type. To be honest with you guys, I don't know. You guys could have it as easy as number 8 or as a little step like number 9. The program that I use to create the test or the worksheets or all stuff that once I make, I just say from these, do 2. And the computer chooses which programs to give you. To be honest, what are you guys going to get? I have no idea. Because I just get him, do 2, and then do me a favor and give me the key. So I don't want to work him up. So I get the key and that's great. So I have no idea what you guys are getting. Like I said, it's randomly chosen by the computer. So now, any questions from 7 through 12? No? All right. Let's move on to question number 13. I know when we covered this, there was 3 choices. We had 3 circles. Let's call those circles. One thing was the angle. The corner of an angle was touching the circle. That was one thing. Another choice that we had is we created 2 chords and the angle is somewhere inside the circle. And the third one we had is the angle is outside of the circle. Those are the 3 choices we covered. This one, if you notice, the angle is touching the circle. There's 2 ways of how we do this. One way, this is 80 degrees. This angle is 80 degrees. So the arc that it creates is twice as big. So I'm going to call it 160, the arc. But then I realized that what I'm asking, what I've been asked for, this angle, let me call it x, this arc and 160 make a circle. And I know circles 360, so if I already have 160, how big is x? What is it? 200. Thank you. Twice of 80. 80 times 2. So once again, the angle is 80, so times 2 is 160. So that's how we knew this arc was 160. The whole circle is 360. Right? We know the whole circle is 360. Part of it is 160. The remaining should be 200. So that's one way of doing this. Now let me move on to a different question. Let me take a look when that angle is inside the circle. So let me skip to question number number 19. So notice how I'm looking at the corner, the angle, 70 degrees. I know the other numbers are also in degrees, but those are arcs. I'm looking for an angle, a corner. So 70. So I'm going to start with the number 70. This is going to equal something. Right, 70 degrees. Then it's going to equal to a fraction. On top of the fraction, I'm going to write the 2 arcs. The 2 arcs, I mean 75 and x. So we're going to add the 2 arcs. Let me just go x plus 75. But I'm going to add the 2 arcs. And then divide it by 2. One way, I told you guys when we covered this, one way you guys can remember that this is addition, because these 2 arcs, they look like a crooked plus sign. So we add. All right. Notice that if my fraction was all numerical, so nothing but numbers, I could work it out. Because my fraction has a letter, let me get rid of fractions. The way I'm going to get rid of fractions, I'm going to multiply both sides by 2. Because that way these 2's cancel out. So I'm going to have 140 is equal to x plus 75. Now my 75, let me move it to the left side as a minus 75. So I'm going to get that x is equal to 65. So once again, when the angle is inside the circle, you have 2 arcs. On the fraction, you add the 2 arcs. Now let me erase all this. Let me move on to something when we have the angle outside. So I'm looking at number 25. So I look at the angle, the corner, the measurement, I don't know it, so I'm going to call it x. So I'm going to start with the angle. Always start with the angle, whether it's a letter or a number. Notice that on the previous question, my angle was a number. And then here, I subtract the two arcs. Notice I have two arcs. I'm going to subtract the two arcs. So I'm going to go 145 minus 65. The order does matter. I put 145 first because I want my answer to be positive. That's the only reason why the order matters. And then at the bottom, obviously, 2. The whole fraction is numerical. We can work it out. On the top, 145 minus 65, that's 80. So my fraction is 80 over 2, better known as 40. That's it. If your fraction is all numerical, just work it out. If there's a letter in the fraction, get rid of fractions, like I did on the previous example. All right, from these kind, notice I gave you guys plenty of review. On the review, I have questions number 13 through 30. So I gave you guys plenty of review of those because there are 6 of these on the final. So there's 6 of these kind on the final. That's why I gave you guys plenty of review. Because there's 6 of them. Yes. 26. All right. Looking at number 26. This big arc is x. I need to know the two arcs. So this little one, I'm going to call it 360 minus x. That's how big the little one is. So I'm always going to start with the angle, the corner. In this case, 70. And it's going to be equal to a fraction. Remember, order matters. I'm always going to start with the biggest one. So I'm going to have x. Then I have to subtract the little one. So I have to go minus 360 plus x. I'm calling it plus because I'm subtracting a negative. Right? When you subtract a negative, you put plus. So that's why I have minus 360 plus x. And obviously over 2. Before I get rid of fractions, let me simplify the top. X plus x, I'm going to call that 2x minus 360. Right. I call it 2x because I'm adding, so don't call it x squared, because that's multiplying. All right, now let's get rid of fractions. Multiply both sides by 2. So those 2's go away. I'm going to have 140 is equal to 2x minus 360. My minus 360, let me move it to the left as a plus 360. So I'm going to have 500 is equal to 2x. So I think we can agree that x is equal to 250. I know half a circle is 180. 250 is more than half. And if you look at x, it's more than half of the circle. So it makes sense. All right, any other questions? Which one? 27. The angle's outside, so I'm going to start with 39, which is the angle. And here I have to subtract my arcs. One of them is x, the other one is 95. I start with the big one. So I'm going to go x minus 95 over 2. Since there's a letter in the fraction, let me get rid of fractions by multiplying both sides by 2. So I get 78 is equal to x minus 95. My minus 95, let me move it to the left as a plus 95. So we're going to finish with x is equal to 78 plus 95, 173. 173 is almost half of a circle, and if we take a look at x, it is almost half of a circle, so it makes sense. Any other questions from 13 through 30? 28? Okay. This little one arc is 105. I can call this one, this bigger arc, 360 minus 105. There's a whole circle minus 105. So 360 minus 105, which is better known as 255. So I'm going to start with the angle, which is x. I have to subtract my two arcs. So 255 minus 105 over 2. I went 360, which is the whole circle, minus 105.
So the whole circle is 360.
The whole circle is 360. All right, so it's all numerical. 255 minus 105, that's 150. So x equals 75. Once again, from 13 through 30 on the review, there's 6 of these on the final. Any other questions up until 30? All right, so let's take a look at 31. See how the 38.8 is by the point in the center? That means the whole diameter is 38.8. So the radius is half of that. So I'm going to say this radius is 19.4. That's the half of 38.8. Right? Radius is only half of the diameter. So that is 19.4. I'm going to say this other radius, it's also 19.4. There's even another radius there. The other radius is here. And we know that it's also 19.4. So the way I'm going to set this one up, I'm going to say x plus 8.5 is equal to 19.4. Because notice how x plus 8.5, it's a radius. And I know the radius is 19.4. So that's why I said x plus 8.5 is 19.4. Then just to finish it, subtract 8.5 on this side. So this is 10.9. Or, yeah, 10.9. So from these questions, 31 through 36, there are 2 of these on the test. And I know when we cover these, I made it more difficult. Because I had you guys sometimes solve it by Pythagorean Theorem. And then I even made it more difficult. I had you guys solve for a y, you guys solve for an x. My thing was like, let me get you guys ready. By then, you guys were able to do it, so you should be able to do these. So these are a little bit easier. Yes.
For 32, would we use 9.1 or 3.5 as the radius?
So the radius, 9.1 is only part of the radius. A radius will be 16.3. Because it has to go from the center all the way to the edge.
Yeah, so it's x plus 13.5.
So x plus 9.1
So yeah, that was right.
is 16.3, yes. X plus 9.1 is 16.3, yes. Because the 13.5 is this part right here. But we don't need it. All right, any questions up until 36? You guys will have decimals on these. I know certain times I avoid, most of the time I avoided decimals, but these you guys can deal with. They're not that bad. Okay, so then, let me move into number 37. There's a right triangle. I know 2 sides. I need to find the third one. So I think of Pythagorean Theorem. A squared plus b squared is equal to c squared. Find the missing side of each triangle. Leave your answers in simplest radical form. So since I have to do with the squares, let me square them here in the triangle before I write them out. I know 4 squared is 16. 12 squared is 144. X squared is x squared. I squared each of my numbers. The hypotenuse is always opposite from 90 degrees, so the hypotenuse is 144. So the way I'm going to write this will be x squared plus 16 is equal to 144. I'm not going to square these again because I already squared them once. So don't square them again. My 16, let me move it to the right as a minus 16. So I get that x squared is equal to 128. So if x squared equals 128, I'm going to say x equals the square root of 128. And then simplify the radical. What I mean with simplify, 128, I'm thinking of 4 times 32. 32, I'm thinking of 4 times 8. I see a group of 4. Even though I can split them, I'm just going to group them up. My 8, I'm thinking that as 4 times 2. And my 4, I'm going to split it as 2 times 2. So I get another group. Notice I have 2 groups. So for my answer, the number outside of the radical, multiply your groups. 4 times 2 gives me 8. Inside the radical, any single, 2. If you have no singles, no radical. Like if I didn't have the single 2, it would just be 8. So my answer is 8 radical 2. Number 38. Alright, looking at number 38, let me square everything. X squared is just x squared. Radical 10, when I square a radical, those are pretty easy, because I'm just going to get 10. The number inside. When you squared 2 radical 3, when you square a number outside and a number inside, when you square that, make sure you square both. So if you look on the outside, 2 squared is 4. Radical 3 squared is 3. Remember I said when you square a radical, you just get the number inside. But together, 4 and 3, I'm going to get 12. So when there's a number on the outside and a number on the inside, square both. 2 squared. 2 squared is 4. Radical 3 squared is 3. Combined, 4 times 3 is 12. So when there's a radical and there's a number outside and a number inside, squared both of these. So now, I know my hypotenuse is opposite from my 90. That's my C. So let me write this as x squared plus 10 is equal to 12. I'm not going to square them again. I already did. My plus 10, let me move it to this side as a minus 10. So I get that x squared is equal to 2. So that means that x is the square root of 2. That cannot be simplified anymore. So that's it. Do remember that I want to give you guys a chance to get a note card size. Whether you guys have a note card as a note card chart or make one with a piece of paper, but note card size, not paper size. Note card size, you can bring notes on it. I'll let you guys use notes because I know we have a bunch of formulas. I told you guys that in geometry, you guys want to learn more words and more formulas. Just words. You guys want to learn more words than you guys learn in your English class. We had a lot. Now, any questions? From this last section, there's 2 of these on the test. So once again, any questions? 17? And which one, 18? Alright, so let me take a look at 17 and 18. So 17, the angle's on the corner, so let me call it x. So the angle's half of 150. So in fact, one way we can create it is the angle is 150 divided by 2. So I'm going to say that angle is 75. Remember, when the angle's on the circle, the angle's half of the arc that it creates. So x equals 75. Now looking at 18, the same idea. This is x, so I'm going to say x is equal to 130 over 2. Notice I always start with the angle. I know for the others here that have 2 numbers, 2 arcs, but notice how this one only makes 1 arc. So this one we're just going to finish with x equals 65. Right, the angle is half of the arc when it is on the circle. Any other questions? All right, let me take roll really quick.